Today in geometry, we're going to be focusing on similarities as we begin chapter 7. And with similarities, we have ratios and proportions that we look at. And being able to solve for ratios and proportions is kind of a big idea, because to be able to solve similarity later on, we're going to need to be able to do this. So this is kind of a big review section that we're going to deal with today. So first of all, let's just talk about a little bit about vocabulary words. A ratio is when you kind of compare two quantities. So maybe it takes you 5 hours to do something, and it takes me 7. So that would be a comparison of what we're doing here. A proportion are two ratios that are equal to each other. So 1/4 is equal to 5/20. If you want to make sure that you follow that proportion, you know it's right, kind of two ways to check it. One is if it's a simple number like this, I can see to go from 1 to 5, that would be a multiple of 5. To get from 4 to 20 is also a multiple of 5. So on something like this, it's easy to see it's the same number to get from one to the other. Another way to do it based on this law of proportions is that if I cross multiply, they should be equal. So whatever I get for A times D, it should give me the same thing as I do B times C. And that's going to serve us well in the examples that we're going to look at today. So let's look at a couple. Okay, now on these first problems, let me just move this line on. And I'm actually just going to black out half the problem so we just focus on this part. On this problem, we're going to cross multiply. So if I cross multiply, in this direction it's going to be 7x. If I cross multiply in the other direction, it's going to be 12 times 5. So 12 times 5 would be 60. Now if I want to figure out what x is, I can divide it by 7. And probably you and I are both looking at this going, this doesn't go in evenly. It's going to be some decimal or something like that. So you kind of have two choices. If I go through and I were to take 60 and divide it by 7, I get a decimal, which if I were to round it would be like 8.57 or something like that, because it keeps going. A lot of people may also take this and make it a mixed number and say, okay, well 7 would go into 60 8 times, and I would have 4 left over. So it would be 8 4/7. Now you'll see kind of a mixture of answers in this section, so really both of these are ways that we can look at the same kind of problem. Now let's take a look at this other problem that we have here. In this one it's going to be the same idea. I'm going to cross multiply the two pairs that I have. So in one direction it is 8y, in the other direction it's 4 times y plus 3. Now it's really important that you put parentheses around that y plus 3, because a lot of people will write 4y plus 3 and not do the parentheses and then screw their whole answer up. So now if I were to distribute that 4 on the other side, it's going to be 4y plus 12. Subtract 4y. And then I have 4y equals 12. Divide it by 4. I get y equals 3. Now it is pretty important that you're paying attention to the fact that when you get these answers, you may have more than one variable like we did here where there's more solving, or it may be some more simple solving over here. So kind of something to keep in mind. Okay, let's see how we can actually use this. Okay, here's a perfect example of one we're going to see in this section. And I'm actually just going to highlight as we go. So a scale model of a car is 4 inches long. The actual car is 15 feet long. What is the ratio of the length of the model to the length of the car? So really you have two different things to kind of think about in this one. And I do want you to remember that if it's a ratio, that has to mean that's some kind of fraction here. And they say model to the length of the car. So really, if they're saying that model goes on top, whatever they mention first goes on top. So it's model really over the real car. Now in this one they tell us that the scale model is 4 inches and the actual car is 15 feet. Now the big problem for us is we're comparing things that have different units. This is inches on top and this is feet on the bottom. So if they were the same units, they'd be a lot easier to solve. So if I want to change this, since 4 feet is not an easy thing to change into inches, let's change this 15 feet into inches. So I'm not going to do anything to this one to begin with. Now to take feet and switch it into inches, I would have to actually go through and multiply it by 12. Because there are 12 inches in every foot. So if I do 12 times 15, I'm going to get 180. So it's 4 inches over 180 inches. Now this is where the kind of easier things are to simplify. First of all, same units cancel out. I have 4 and 180, and actually I know that 4 is going to go evenly into both of those. So if I were to reduce these both by 4, I'd end up with 1 over 45. So really what that tells me is that 1 inch in the model is going to give me 45 inches in real life. So being able to solve these and know exactly what this proportion is here is kind of a big deal, because that is what architects use and engineers use and all those kind of people use who actually build things and build small models first before they actually figure out how feasible it is to do, the larger model. Okay, let's take a look at a couple more. It says complete if this, then this. So first of all, if I were going to do this, I'm going to use my highlighter. You know how I am with the highlighters. A and B. So if I went over here, I know there's B. Something's going to have to go there. If I look at the other one, I have 4 and 12, and I see the 12 over here. Now, I did the highlighters to kind of help me. A and B have to be in the blue. So in this one, if the blue here is for B, this is going to have to be A down here. Then if I do 4 and 12, there's 12 here, which means that there's going to be 4 here. So that finally, that missing fraction piece that we have should look like this, that last one. Highlighter technique is a really good one to be able to make sure you have things lined up in the appropriate order and that you have things pairing together. So pretty easy. Okay, let's try one more here. Now this is cross multiplying, so it's going to be this times this. So 5n equals 2 times 35. So 5n equals 70, because that's of course 2 times 35. Divide by 5. Oops, I get n equals 14. What the heck? Hang on, I'm going to be OCD about this and fix it. Okay, pretty simple. Now if I think that's the answer, I could put 14 back for n and make sure when I cross multiply they both equal the same thing. That's a way to check yourself. Okay, now in this direction. So 3x and 2 and x plus 1. So 3x equals 2x plus 2. All I did was distribute this 2 to both items. I'm trying to make this look a little simpler. Subtract 2x. So 1x equals 2. So x equals 2.